Number 4. Let's see. What can we reduce? A lot of pieces there. At least it's already factored for us. X plus 1s will go away. The x's will go away. The 2 and the 4 will reduce to 1 and 2. Although be careful, there's still a minus sign there, so don't forget about that. And then this x minus 3, how am I going to handle that? Okay, that's a good way to say it. X minus 3 squared is x minus 3 times x minus 3. And that makes it easy to see that you can cancel one of them. This is a great place to remind you to be neat when you work so that you don't lose track of like that minus sign. And then in the bottom there's a 2, an x plus 3, and an x minus 3. And number 5 is a similar problem, but you've got to factor it yourself and then look for the canceling. What we haven't done in a while is the inequality stuff, like 8 and 9 and 10 and 11. Anything from 8, 9, 10, 11? Or I can pick one from 8, 9, 10, 11. You're nodding yes. Let's see, 10's got a lot of issues with it. 11 looks awful. Should we do 11 just because it looks terrible? It's already factored, so that's nice. This is a wrench problem for sure. Let's see. We want zeros at the top, zeros at the bottom. Put them on a number line, test the intervals. But we remember we have a trick on testing the intervals, right? Like we don't have to test all of them. We know they're going to alternate, except for a double root. So know the shortcut, but know when it works. So x equals 0, x equals negative 1 are zeros from the top. I don't want to put them on the number line yet because I want to figure out what all the numbers I have to work with here. X equals 3, x equals 7. And you know what? I should probably note that negative 1 is a double root and 3 is a triple root. So triple roots, it will alternate. Double roots, or the easier way to remember it is it will alternate twice for a double root. So it switches and switches back. For a triple root, it switches back, and switches again. All right, let's put these numbers on in the right places here. So negative 1, 0, 3, 7. Again, I'm not concerned about whether the scale looks right. I'm more concerned about you put them on in order from smallest to greatest. I won't mock you publicly, but I would be tempted to display your work without giving you credit, of course, for the person somebody's going to put these numbers on out of order. And obviously that just messes up the whole problem. All right, open circles or closed circles for 0 and negative 1? Why closed? Because there's a line underneath. Yep, the equal to part. What about 3 and 7? Bottoms are always open. Why are bottoms always open?
Because they can never touch that.
They can never equal 0.
Right. You can't divide by 0, so those have to be open. I don't have to label this a double root and a triple root, but if I'm thinking about using the shortcut, I probably should. I got to test something. Probably should test multiple somethings. Negative 2 seems right. And then maybe I'll test 8. Like that should make everything positive probably. And that'll confirm my alternating guess. So I'm going to shortcut it, but I'm not going to like bare bones shortcut it. I'm going to verify my shortcut. So let's try negative 2. So negative 2. Be careful right off the bat. -1 but squared, -5 cubed, and -9. And we want to know if that's greater than 0. That's a whole bunch of negatives to worry about. So the top is positive, positive, and the bottom is negative, negative. So positive number greater than or equal to 0. True or false?
Yes.
Yes. So I will shade there. So what about the shading between -1 and 0? Yes or no?
It would also be shaded.
It would be shaded. Why am I not alternating?
Because it's a double root.
There's a double root. So that's a yes.
And then it won't be shaded.
Then it's a no.
Yeah.
And then it's a yes, because a triple root won't, well, it changes 3 times.
And then it's a no.
That's a yes. And we think that's a no. Let's check 8 just to make sure. If 8 turns out to not work, I'll feel good about all the other places. So -8 times 9 squared over -11 cubed times 1. And again, so weird numbers, but I don't really care about the numbers. I only care about the positives and negatives. Because, nope, it's not -11. It's 8 minus 3 is 5. Hopefully I would have caught that when it came to the shading or not shading. Hopefully I'd have realized something's not right here. But better that you caught it ahead of that. So negative times positive is negative. The bottom's all positive. So a negative number greater than 0. No, that's not true. So 8 is an X, which is what we thought. So we feel pretty good about our answer, our number line. Now we need to write an inequality notation. So that would be X is less than or equal to 0. I don't have to worry about the -1 because we just cruised right past it, right? So we don't have to worry about it. X is less than 0. And 3 is less than X is less than 7 without the equal signs because of the open circles. Yeah, that was a good one. We had top zeros, we had bottom zeros, we had double roots, we had open circles and closed circles. It's one of those, if we were to give you one question from each unit, we could give you that one question and make it a 5-question test. Which is terrible, because then if you make the one mistake that I almost made down here, 20 points off.
Yeah, but make the bonus 20 points.
And then make the bonus worth 20 points.
That would actually be.
You're never going to get a bonus for, I shouldn't say never. I can't imagine a circumstance where I give you a bonus of 20 points.
Is it going to be another average or shade? Because this seems popping up from like every homework you do.
Haven?
What's this partial fraction?
So you want to do number 12 or number 13?
I don't remember if we covered it. We might have. I just don't remember.
Let's do 13 because it looks like the harder one. Partial fraction decomposition.
That just sounds.
Sounds fancy. Factor the bottom first. This means, this is the Jeopardy game, right? Like, who did we add? What fractions did we add to get to this as an answer? Well, one denominator would have had to been x minus 5. The other would have to be x plus 3. And I don't know the numerators. That's the job to find.
I remember this one.
Okay. Shall I keep going on this one?
No, you're.
Anybody else want me to keep going on this one?
I mean,
Jason.
I'll take it.
This is easy, or nah, go ahead and review this one.
It's pretty easy.
Keep going. Okay. Let's see. Let's multiply everybody by the common denominator. That way all our fractions will go away. So on the left, I get 21 minus x. And I've said this before, but again, I think this is the most dangerous step of this problem. And I think it's because people are doing a lot in their head and they mess something up. on this term, the x minus 5 cancel, and that leaves a times x plus 3. On the next term, the x plus 3's cancel, and it leaves b times x minus 5. Again, I feel like if you make it that far, you're going to be fine. It's just getting to that point is the hard part.
I swear they're like purposely doing it.
Let's try x equals negative 3 because that will wipe some stuff out. So 24 equals a times 0 plus b times negative 8. So that means that b is equal to negative 3 because we wiped out the a term. What's another good value of x to pick? 21 minus 5 is 16. A times 8 plus b times 0. So a is 2. And I'm not done until I rewrite the problem, although on the multiple choice test, they're all going to be rewritten, so you'll know that you're not done yet. So a over x minus 5, 2 over x minus 5, plus b, negative 3 over x plus 3. And you know that that's the same thing as if we wrote them in a different order. Right? So somebody else might have set up the problem a little bit differently than you. Or when you're doing a multiple choice test, you get this, you look at your answers and you see that. Like those are the same thing. Yes, sir?
So, you might have just accidentally happened to gloss over her question, but for the rate of change, average rate of change,
Yes?
is that going to be the benefit of that?
I don't think so. I don't think I saw a bonus. Was that what she asked? I couldn't hear. I'm sorry. I don't want to commit to it, but I don't think so.
Okay. So you know what it is?
I'm mentally blanking. I did it last night to work it and make sure it looked good. I don't remember.
Okay.
Do we need to do anything with rational graphs? So like asymptotes, slant asymptotes, domain, holes, vertical asymptotes, intercepts. Slant asymptotes. I can do 20. What makes 19, or what makes 20 a little more difficult than 19? I'm dividing either way, but 19 I can synthetic divide. Synthetic divide. On 20 I've got a long divide. Alright, so something times x squared gets me to 2x cubed.
X. 2x.
Good. An x would get the x cubed, a 2 would get me to 2x cubed. Multiply it back. 2x cubed. Hey, they match. That happens every time. That's why we picked the 2x to make that work. 2x times 3 would be 6x. Although be careful, make sure we keep things lined up here. And then to subtract those, x squared minus 11x plus 7. Right, that's how we long divide.
Okay.
And then something times x squared gets me x squared. That's an easy one. In fact, that could be done there, right? Because the remainder doesn't matter for slant asymptotes. So my answer is y equals 2x plus 1. I haven't really finished the long division problem, but I don't really need to. I mean, I can, but but that would be my remainder. Negative 11x plus 4.
Well, I never asked for the remainder.
Not in this section. My guess would be that would be a great multiple choice distractor. Just put the remainder on there as one of the answers.
I'm looking at number 6 right now, and I have questions. I don't know, maybe it's like algebra 2 I got to well, you might have to work it a little bit to get around that.
Okay. Did you fix the top, fix the bottom, keep it, change it, flip it?
Yeah, I'm
Okay.
at the part where I'm about to multiply it.
Okay. Because there are multiple ways to do this. So when you said you remembered it from Algebra 2, you might have done it a different way. But if you fix the top and fix the bottom, so 5 minus x over 5x over x minus 5. Now I'm ready to keep it, change it, flip it. And I think I see where the potential problem is coming in. So keep it, change it, flip it.
Yeah, so you can't cancel them because they're not the same, but wouldn't it be negative 1 or something?
Yes.
Okay.
Very good. I don't remember us doing one of those. Yeah, 5 minus x, x minus 5. Those aren't the same thing, so you can't just cancel them. But they're close to the same thing. They're off by a minus sign.
Okay.
So you can do a couple things. You could just cancel them and put a negative 1 in there. That's the easiest thing to do if you recognize that's what's happening. If you don't like that, then you factor out a negative, and that makes that top one positive x and a minus 5. And then it becomes a little more obvious that you can cancel the x minus 5s, and you're left with a negative. Good question.
So you can just get to the negative 1.
But yes, if you've done this enough times, you're like, wait, I know what this is. That's negative 1. Let me just cancel that to negative 1. Definitely. Asymptotes, intercepts, equations, that was more recent. Other questions? Okay, then I'll give you time to work on it. Again, due on Thursday is worksheets 4 through 7. Oops. It's a block day. I think it's a 30 question test. Most of it, vast majority of it's multiple choice. Timing shouldn't be an issue. In fact, we may have a few minutes on Thursday